Now let's continue our study of the properties of sequences. This time we'll look at monotonicity. This is the increasing or decreasing behavior of sequences. I'll start with the definition. A sequence AN is called increasing or strictly increasing. There will be two versions of this property. If AN is less than or equal to AN plus 1, so the nth term of the sequence is less than or equal to the following term of the sequence n plus 1, AN plus 1, it is strictly increasing if it's strictly less than the next term. Or to put it in a different way, each term in the sequence is greater than or equal to the previous one, or each term in the sequence is strictly greater than the previous one. That is when we say that the sequence is increasing or strictly increasing. So similarly, we can talk about a sequence that is decreasing, or again, there can be a strict version of this property, strictly decreasing. Now, this happens if each term in the sequence is less than or equal to the previous one. So the n plus first term is less than or equal to the previous one, and it's strictly increasing if the n plus first term is strictly less than the previous one, the nth term. Okay, so this is when we say that our sequence AN is decreasing or strictly decreasing. These inequalities have to happen for all indices. So this always has to be the case, not just on a few occasions, but always has to be like this. So to give you a few examples and to test your understanding, I would like you to look at the following sequence. AN is equal to 2 to the n. Again, these are the powers of 2 in a sequence. And I want you to decide and use the box below, or use the options below to decide whether it's a sequence that is increasing, strictly increasing, decreasing, strictly decreasing. These are your options. You can select more than one of these if it happens to be the case. Stop the video and vote for your answers below. Okay, I hope you stopped it. So the point is that this sequence of the powers of 2 is increasing because each term is greater than or equal to the previous one. So since, let me just try to write this in a way that reflects the definition. So it's true that 2 to the n is less than or equal to 2 to the n plus 1. Okay, so this is why I'm saying it's an increasing sequence, and it's strictly increasing because it's actually a strict inequality, strictly greater. So for the next example, I want you to consider the sequence AN being equal to 1 over n. So this is the sequence of reciprocals of natural numbers. What about this sequence? Pause the video and select the answer below. Okay, so I hope you paused it and selected decreasing and strictly decreasing, because for this sequence, the nth term is 1 over n, the n plus first term is 1 over n plus 1. So notice that we are dividing 1 by a bigger number, a greater number here, meaning that will lead to a smaller result. So for each term in the sequence, that the next one, the one after that, is strictly less. So both of these inequalities hold true. Okay, so it's decreasing and strictly decreasing. For our third example, I'll give you the following sequence. AN is equal to 3 for all indices. So it's equal to 3 for all indices. What about this sequence? So pause the video and select your answer below. Okay, so this sequence is increasing and decreasing, but not in the strict sense. So I will try to indicate that AN, which is 3, is less than or equal to 3, which is also AN plus 1, and similarly it is also greater than or equal to AN plus 1. So this means that these non-strict inequalities hold because they are all equal. So let me again use the visual representation, which I have used in the previous video, is to plot the sequences. So just to give you an idea, I will just sketch these sequences. For our first one, for the powers of 2, the way you see it's increasing, you see these marks getting higher and higher. So in value, they are getting larger and larger. So this is an increasing sequence. Actually, let me use the corresponding colors. So this would be an increasing sequence. Similarly, we would have, so for the sequence AN equals 1 over n, we would have something like this of a behavior. We would have a sequence that is decreasing. Okay, and so for our third example, what we had, a sequence that basically stays the same. So all of its values are equal. So it's a weird way of saying that it's both increasing and decreasing. Okay, our last example, let me give you a sequence that is -2 minus 2 to the nth power. So what about this sequence? Is it increasing, decreasing, strictly increasing, or strictly decreasing? Pause the video and vote for your answers. Okay, so for this sequence, you had to select the option that is none of these things, because this sequence it keeps changing sign as it progresses. So first we have -2, then we have +4, which is something that is greater than the previous term, but then we get -8. So that is again going down. Then the fourth term in the sequence is +16. Now it went up. So what it does, it's jumping around up and down. It's neither increasing nor decreasing. Okay, I hope you got these right, and I'll see you in the next one.